when we look at proof number 4, I hope all of you can begin to see that we could have multiple triangle situations here. We could be talking about these two little top triangles. We could be talking about the bottom two triangles. We could end up talking about the kind of halvesies triangles, or those are all most likely congruent. We could also potentially have an interesting discussion about the top triangle or an interesting discussion about the bottom triangle. So again, multiple perspectives on this picture, kind of take it all in, then we go back and we deal with what given we have, what we're trying to prove, and where we go from there. So what am I trying to prove? So if I grab my yellow highlighter again, I'm trying to prove that YZ is equal to WZ. So again, segments or angles as my prove line most likely come from proving two triangles congruent and then saying that those angles or sides are congruent by CP/CTC. This potentially could also be some sort of isosceles triangle theorem if I could maybe find out something about this angle or that angle. So all of that kind of goes through my head before I even start working. Kind of gather all of my thoughts together. So let's go back to the given. I know that YX is equal to WX, and I know that ZX bisects angle YXW. So this is my given information. So I'm going to mark my given. I can't mark this bisect bit because those are just words. But what does my given give me? It gives me that ZX is going to bisect this angle. So that tells me that angle YXZ is equal to angle WXZ by definition of bisector. So I can come in and I can mark these angles congruent. Now remember where I want to go. This is a crucial piece. If I start to trace this triangle down to this angle and this one down to this, I could stop at these two top half triangles, but those don't tell me anything about the bottom half where I want to go. But if I look at this whole middle piece that is shared, and I look at kind of the halvesy triangles, my next line tells me that I should say that XZ is equal to XZ, the entire piece, by the reflexive property. Now, I could stop at O and say XO equals XO by reflexive, but then I would only be proving the top two smaller triangles congruent when I need the bigger triangles. So I now have enough information by side, angle, side to say that triangle ZYX is equal to triangle ZWX. This is fold in half, watch your order, and that happens by side, angle, side. And once I know that YZ is equal to WZ by CP/CTC, because that is a corresponding part of a congruent triangle. So let's go ahead and look at this last coordinate proof here. Now, coordinate proofs are a little bit different because they deal with only this specific situation. Regular proofs deal with all situations. This deals with just this specific information. Determine if they are congruent. So that means I either have to prove by side, 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 angle, side, angle, angle, side, side, angle, side, or HL. I have to prove one of those. The only way I can prove angles in a coordinate proof is by proving perpendicular, and I can do that with slope. If I can prove that they're perpendicular, I can say they're 90, and I can either use that for HL or I can use it for one of my angles. Otherwise, there is no way to prove anything about the angles. When I look at these pictures, it's highly unlikely that any of these lines are perpendicular. So then my only other choice is to prove sides with the distance formula. So I have to, here's my plan, I have to show all 6 distance formulas, and I need to show 3 pairs of corresponding sides equal. So I have to get everybody to match up. So the best way to do this is to just be very deliberate and clean with your work. I highly recommend that you write down the coordinates. J is going to be at 1, 2, 3, 4, negative 4, 1, 2, 3, 4. L is at 1, 2, 3, negative 3, 0. K is at 3, 4, 5, 6, 7, negative 7, 1. R is going to be at 2, 1, 2, 3, 4, 5. T is at 1, 2, 3, 4, 5, 2. And Z is at 1, 1. So we're going to go through and we're going to do our distance formula work in a very deliberate way. We're going to talk about the distance of J to L. We're going to do the distance of L to K. We're going to do the distance from K to J. Then we're going to repeat that with the distance from R to T, T to Z, and R to Z. Why don't you go ahead and pause the video right now, do that work, and then restart the video, and I will pick up with all that work completed. So just as a quick check-in, the first triangle, I ended up with 2 sides equal to the square root of 17 and 1 side equal to the square root of 18. I would not worry about going to decimal approximations. I would just leave my answers as square roots because it's very easy to compare them at that point. Just as a point of emphasis, remember when you square negative numbers, you always get a positive number. Don't trust your calculator. Be sure to use your brain. Go ahead and work the next triangle and check back in. So now that I've finished the distance formulas for triangle RTZ, you can see everybody matches up, but I'm not done. So I need to draw my conclusion. Therefore, I would say that JL equals RZ. I could say that LK is equal to TZ, and I could say that KJ is equal to RT. Therefore, triangle JLK is congruent to triangle RZT by side, side, side. Now there's some room. You could write all 3 sides are equal, or pairs of corresponding sides. Sides correspond, therefore. But what I have to see is this, and I have to see a congruency statement. In this particular problem, there's some room for a different lineup because I have 2 isosceles, but in essence, you need your corresponding pieces. So I would start with these and making sure these correspond and get your congruency statement right. Good luck with your homework.